Good day and welcome to Mission Control Houston. Today is Wednesday, November the 6th, 2013, and this is Space Station Live. Expedition 37 crew continues to work on a variety of research and space station maintenance activities today, as well as to prepare for the launch and same-day arrival of the Expedition 38 crews that will be joining them tomorrow. Here in Mission Control, the flight director on duty today is Scott Stover, and Christy Bertels is the spacecraft communicator, talking with the crew along with some help from Hal Getzelman. On board the International Space Station, we have NASA astronauts Karen Nyberg and Mike Hopkins, along with the Expedition 37 crew commander, Russian Fyodor Yurshkin, and his Russian colleagues, Oleg Kotov and Sergei Ryazanskiy. Also on board is Luca Parmitano of the European Space Agency and the Italian Space Agency. They are getting ready for the arrival tomorrow morning of NASA's Rick Mastracchio and Roscosmos's Mikhail Turin and the Japan Aerospace Exploration Agency's Koichi Wakata, who will later become the first Japanese commander of the orbiting outpost when they head up to the International Space Station and join with the existing 6 crew members to bring the total number of humans in orbit to 9 for the first time since October 2009 later tomorrow. Crew on board the space station continuing to prepare for a spacewalk that's planned for Saturday to make preparations outside the station for a future Russian research module and to display an Olympic torch that'll be arriving aboard the Soyuz carrying Mastracchio, Turin, and Wakata. Mike Hopkins spent much of his day working on the body measurements experiment, which is aimed at collecting anthropometric data using digital still and video imagery, as well as tape measures and other devices to measure segmental length, height, depth, and circumference data for all of the body parts, both before, during, and after flight, and he did so with some help from his colleague Karen Nyberg. Nyberg, Parmitano, and Yurshkin also talked with Russian flight controllers on the ground about their upcoming departure from the International Space Station and continued to do a lot of work packing up the Soyuz and getting all of their last-minute items ready to go home. Karen Nyberg also worked on the in-space experiment with the microgravity science glove box. That experiment works with colloidal materials that can be affected by magnetic fields. Colloids are those types of liquids that have solids suspended within them. Parmitano also took part in the biological rhythms experiment, which studies the effect of long-term microgravity exposure on the heart and cardiac autonomic functioning. He was analyzed during a 48-hour-long electrocardiogram. Fyodor Yurshkin, Oleg Kotov, and Sergei Ryazanskiy reviewed the procedures for the arrival of the Soyuz TMA-11M carrying Mastracchio, Turin, and Wakata. And Kotov and Ryazanskiy also reviewed procedures for their spacewalk on Saturday and took a look out the windows to review their spacewalk translation paths and work zones as they get ready for that excursion. Meanwhile, in Kazakhstan, on their last day before launch, Mastracchio, Wakata, and Turin attended the Russian Crew Readiness State Commission ceremony and participated in a final press conference. They're going to be awakened about 1:45 p.m. Central Time today to begin their launch day activities, with launch scheduled for 10:14 p.m. Central Time tonight, which will actually be 10:14 a.m. Baikonur time on Thursday. We have a full set of NASA television coverage coming up today and tomorrow for that launch. Launch coverage begins at 9:15 p.m. and a launch, of course, expected at 10:14 p.m. On Thursday at 3:45 a.m., we'll begin our Soyuz docking coverage with docking planned at 4:31 a.m. And then we'll begin our Soyuz hatch opening coverage at 6:15 a.m. with the Soyuz hatch opening expected at 6:40 a.m. And then our Expedition 38 docking and hatch opening video file will be coming to you at 8 a.m. And then we'll take another look at all of that activity tomorrow, 10 a.m. Central Time on our regular space station miles an hour, circling the globe once every 90 minutes. This is Mission Control Houston. We're receiving downlink television pictures live from the external cameras on the International Space Station as the station flies high over the western coast of Africa in the Sahara Desert. This particular track will take them on a southeasterly coast along the western edge of the continent, and then out over the southern tip of Africa, just to the south of the island of Madagascar.
I am ready for my PMC on SSC 15. Houston copies, dialing now.
Karen Nyberg calling down that she is ready for a routine private medical conference, one that happens periodically so that each crew member on orbit can have a chance to speak with their doctors and go over how they're feeling on orbit and confront any issues that they might be having. We're also getting some live television coverage of Mike Hopkins as he works inside the Destiny Laboratory module. Hopkins scheduled to be doing some visual leak inspections of the internal thermal control system now, taking samples from that water-based system that's used to help get rid of the excess heat inside the International Space Station. It does so by interacting through a heat exchanger with an ammonia-based cooling system that runs through the large radiators on the outside of the International Space Station. The internal system, water-based system, so that if any leaks should occur, they will not be harmful to the crew. Ammonia, much better conductor of heat, and so used on the outside, but certainly not something you'd want to have get loose on the inside of the International Space Station, as it could be harmful to the health of the crew. Payload Operations Integration Center resides and coordinates all of the experimental research aboard the International Space Station. Today's topic will be nutrition and well-being for astronauts. And we'll include an interview with Scott Smith, the lead for the Nutrition Biochemistry Lab at Marshall Space Flight Center. Again, that's coming up at 10:15, and then later on in our hour, we'll have a special visit by former International Space Station long-duration crew member Peggy Whitson. She'll be talking about research aboard the space station, in particular microencapsulation, which was identified in a recent set of blogs by International Space Station program scientist Julie Robinson as one of the top 10 research wins of the International Space Station's first 15 years. We are counting down until the 15th anniversary of the first element launch of the Zarya module of the space station. That anniversary will be in 13 days, 14 hours, and 30 some odd minutes. On this Science Wednesday, let's head out to the Payload Operations Integration Center at Marshall Space Flight Center in Huntsville, Alabama now. Lori Meggs is there, and Lori, we're talking about nutrition and well-being for astronauts today, as well as for here on Earth.
Now, it's the ProK experiment. It looks at the nutritional intake of astronauts. It's ongoing, and the nutrition experiment, which wrapped up earlier this year. Dr. Scott Smith, he is the lead for the Nutrition and Biochemistry Lab at Johnson Space Center, and he tells us what we've learned from these experiments and where we're going.
I've always been very happy to say that we were the first blood collection on board the International Space Station. We'd collected blood on Shuttle, we'd collected blood on Skylab, but it took several years until we had the right hardware on board station to allow us to collect blood during flight on station.
Anything you can share with us so far?
We've found several things. The biggest thing I think we found is that we found metabolic metabolism pathway is a very nutrition-rich pathway. It's got several vitamins tied into it, vitamin B6, vitamin B12, folate, biotin, a number of things that are involved, which is why we were looking at it. It wasn't until we started teasing out crew members that had vision issues, crew members that didn't have vision issues, that allowed us to see that there appeared to be a relationship. The striking thing was not only that we had differences in blood levels of these metabolites in individuals with vision issues, the bigger thing, I think, is that we had differences related to these changes in vision. And we're now doing a follow-on study, which isn't really a flight study, although we're doing it with the astronauts, where we're actually going back in and looking at their genes for specific enzymes in this pathway to see if we can then relate the actual genetic information to vision issues.
And how could this help us here on Earth?
Well, it could be a lot of things. I mean, we could still, I would say as a caveat, we're very excited about these data. We think we're going down the right path. We could be wrong. So this could be a fluke. When we look at the scientific literature and the medical literature about this pathway, people with alterations in this pathway also tend to have increased risk of stroke, increased risk of migraines, increased risk of other types of vascular diseases. And it's possible that, again, if our data help flesh this out, that this may also have implications for understanding of health and physiology in everyday humans. And then the second experiment is what we call ProK, which is getting at the relationship of dietary protein, which is the Pro, and dietary potassium, which is the K. And what we believe in that experiment is that the ratio of animal protein and potassium in your diet may have an effect on your bone health. That is, the more animal protein you consume, the more red meat you consume, and the less fruits and vegetables you consume, which are rich in potassium, the higher that ratio, the more bone breakdown you see. So the converse is, yes, that we believe that by modifying the diet, by increasing fruits and vegetables, decreasing red meat, and perhaps increasing fish intake or vegetable protein intake, that may be one way to help mitigate the bone loss that we see in astronauts.
And joining me now is someone who knows about nutrition and our diets and how that affects everyday life is Linda Stakely. She is a nutritionist and registered dietitian at the Huntsville Hospital Wellness Center. Linda, thanks for joining us today.
So welcome.
You heard Dr. Smith and what he had to say. Tell us your thoughts on how that translates to us here on Earth.
Well, when I think about an astronaut's diet, and people that are up at the payload station, I'm thinking of more of a perfect diet because it's been formulated. They've had biochemists work on it. They've had dietitians work on it, scientists. So it's more of a perfect diet. But here on Earth, our diets are not so perfect. And one of the studies that he looked at was the Pro-K. And they're decreasing the protein, but increasing the potassium in the diet. And that has to do with bone density. And so I brought along a plate with me today just to show how we can compute that into real life.
It looks pretty good, actually.
It does. If you would take your plate and divide it into 4 quadrants, what we'd like to see people to do is have 1/4 of your plate as your protein, and this is a 3-ounce portion of chicken, and that's really about all we need. And then 1/4 of your plate would be your starch, and this just happens to be brown rice. But I like to see half of your plate as fruits and vegetables, and I like to see the more colorful vegetables that have the antioxidants in it. But the thing about this is you're getting more potassium when you're eating fruits and vegetables, and so you get an added benefit when you have extra potassium in your diet to lower your blood pressure. So not only does it help bone density, but it helps to lower your blood pressure.
So how much potassium, do we need?
We need probably about 3,500 milliequivalents of potassium a day, and we easily get that if we include fruits and vegetables in our diet. But the problem is we are a meat and potato society, so it's more half our plate's meat and half of our plate is potatoes. So we need to include more fruits and vegetables in the diet to get that potassium that we need. And probably if you're eating 45 to 55 grams of protein for a female, you're getting enough. For a male, probably no more than about 65 grams, unless you're really a weight training, and then you might need as much as 100, 110, or 20 grams of protein. But most people don't need that much, but that's what we end up getting.
We talk about the perfect diets of those in space, but they're sometimes in a stressful situation. Tell us how stress relates to what we eat and how that affects us.
Well, when we're stressed here on Earth, we don't eat right. We don't choose right. And when we feel those stress hormones, we tend to want something salty, something sweet, something fatty, and so we make bad choices. We don't go and eat a good vegetable lunch or dinner. So the stress can cause you to drink more coffee, which is going to increase the stress. It can cause you to drink more alcohol, to skip meals, and to overeat when you do eat at mealtime. So a stressful diet is obviously going to affect your immune system. It's going to affect how you feel, how you perform. So eating more healthy foods and more like Dr. Smith is talking about, less protein, more fruits and vegetables is going to be the healthy approach. But that's not what we turn to when we're stressed. We turn to something sweet. In fact, I asked you earlier, what is stressed spelled backwards?
It is dessert.
It is dessert. And that's what people tend to go to, something sweet, especially women. We oftentimes want that piece of cake, or we want that cookie or that sweet after a meal. And many times it's just because we're feeling so stressed and uptight. And it's that carbohydrate, which releases serotonin. It's that feel-good hormone, and it kind of helps us get through it briefly.
You talked a little bit about the B vitamin, too. Tell us what are some sources of B vitamins?
Well, your B vitamins mainly come from your breads and cereals. But the problem with that is so many of our breads and cereals are highly processed. What you want to look for on your label is 100% whole wheat or 100% whole grain product. So if your label does not say whole grain or whole wheat, then it is a highly processed food. White bread, the Iron Kids bread, the white wheat bread, honey wheat bread, all of that is very processed. And what you really want is 100% whole wheat or whole grain, because the nutrients have not been removed and they're there for us, and they're better utilized by the body than what they just throw in there.
We also talked about bone health. That's a big deal on Space Station. What other factors influence bone health?
Well, there are a lot of factors here on Earth that influence bone health. If you are doing load-bearing exercise, that is going to be a really important thing to help you to strengthen your bones. But also calcium is important, and calcium that has calcium that you also have vitamin D at the same time helps to make those bones stronger. So calcium in the diet, load-bearing exercise, those are important things. And again, too much protein in the diet is not going to be healthy for the bones, here on Earth as well as in space.
How much protein should we have daily?
About 45 to 55 for women and probably 65 to 75 for men. Don't need any more than that. You know, 3 ounces of meat at lunch and 3 ounces at dinner is really going to get us what we need.
I don't know if that's enough. No.
But what happens when we go out to eat, we get 5 to 6 ounces at lunch and maybe even more at dinner. And when we eat so much meat, we don't eat those vegetables, and that's the problem.
All right, and I know it probably excites you to hear about, what do you think when you hear about nutritional studies in space?
Oh, it's wonderful. It's so exciting that they're doing all of this, and then we take that information and we can apply it here on Earth. And I love the fact that the diets that they prepare for the astronauts are so carefully planned to give them everything that they need. And if it were just so here on Earth and so simple, but we have a variety of choices, and we oftentimes make the wrong choices. So maybe all this good information to show how well our astronauts do in space will help people to realize if they just ate better, they would be a lot healthier.
So much good information. Thank you, Linda, so much for being with us today. Linda Stakely from Huntsville Hospital Wellness Center. Now let's take a live look into the Payload Operations Integration Center. They've just wrapped up working on the in-space experiment this morning. They're putting some things away for that and planning for a new crew. So that'll do it for us here from the Payload Operations Integration Center at NASA's Marshall Space Flight Center. Now back to you at Mission Control in Houston.
And we're back now in Mission Control Houston. We're going through a temporary loss of communication with the space station's television cameras as it orbits just to the south of the southern tip of Africa, taking a swing over the southern Indian Ocean, and it'll swing back over the eastern coast of Australia. Everything continuing to work well on board the International Space Station. And coming up at the bottom of the hour today, we'll have an interview with Peggy Whitson, a 2-time International Space Station resident of long duration, an accomplished biochemist. And we're going to be talking a lot about microencapsulation research that was done on her first expedition in the space station, which was identified earlier this week by Dr. Julie Robinson, the International Space Station program scientist, as one of the top research experiments on the International Space Station to date, as we get ready to recognize 15 years of that orbiting outpost with the start of its construction. We'll start off that interview here at the bottom of the hour. And we have a special guest with us here in Mission Control Houston today, two-time long-duration space flyer Peggy Whitson, as mentioned, an accomplished biochemist in her own right with a degree from Rice University in biochemistry. Peggy, welcome.
It's great to be here today.
We're glad to have you on Space Station Live, and the reason we're talking with you today is we're talking about microencapsulation. And I'm going to let you explain it, but the reason we're talking about microencapsulation is because we did a countdown of the 10 top research results and experiments on the International Space Stations. We're getting ready to recognize the 15-year anniversary of the first Element launch. You were one of the early space station crew members on Expedition 5, and you worked with the microencapsulation experiment on orbit. Tell us a little bit about it.
Well, actually, the microencapsulation experiment on orbit was actually, from a crew member perspective, relatively simple. We just put in these canisters and activated them, and what we were doing is building these little, basically, bubbles that can be used in technology as either delivering drugs and various different techniques for application here on the Earth. But we were just trying to build the bubbles and understand what makes them, how to make them the best way and the most effectively. And so we were using the lack of gravity as our tool to see what other variables can influence how these little capsules can be made here on Earth, which is great for us because, up on orbit we can test these things out and find out all the nuances of the different things that influence making these capsules. And what's really, I know it's been since Expedition 5, and that seems like a long time ago, but that's actually kind of how research runs, especially research that involves human beings. It's taken this many years to get these capsules to the point where we're going to actually try and test them here on Earth to carry, in some cases, they're going to carry markers that can be used then by the doctors to visualize where the cancers might be located, so the capsules will go and know how to attack and attach to a particular type of cancer. And then the doctors can visualize that cancer better because the bubbles inside will have little fluorescent or marker beads that can actually be visualized, and the doctors can attack it directly by using ultrasound to visualize it and inject things. It's also a plan for future uses where you would actually put drugs inside those little bubbles, and they would then attack the cancers directly. So it's really exciting that we're getting to that phase where we're taking something that we tested out on orbit, found out how to optimize making these little capsules on the ground by taking out gravity as a variable, and now we can test something in human beings that hopefully will have a future for us in helping to cure cancers, or not so much cure cancers, but to help us fight more effectively cancers as they grow in our bodies.
Well, and that could also, as I understand the way they're hoping to use this in drug delivery, help make cancer treatments a lot less hard to deal with for the patient. Right now, you pretty much pollute the entire body with the anti-cancer chemicals. This allows you to pollute just the area that you really want to target.
Yes, that's a very good point. So it'll be very much a targeted drug delivery mechanism. So it's very exciting. But human research does take years, especially from the concept, the idea, and then to get it to where we're actually testing it in human beings. It does take years, and that's standard here on the ground. When we're doing research, it takes that long. But it's very exciting that something that began on the International Space Station has come this far.
Well, so tell us, as a biochemist, are there any other experiments that are particularly interesting in your view that have come out of space station research?
Oh, well, I have lots of favorites that I've worked on over the years doing different research, but the ones that are most appealing to me are the ones where the crew member gets to interact the most. We do a lot of crystallization, but mostly that's activating and starting an experiment, and zero gravity is the variable that causes these things to happen independent of the crew member. So from a crew member perspective, the ones that are most interesting are the ones where we get to actually be involved and be a part of the experiment. One of the more interesting ones for me, again, that illustrates why we do research in an environment like the space station was an in-space experiment where we were looking at this colloidal suspension of iron particles in a magnetic field. And one day I turned the magnetic field, or the electromagnetic field, and set it at the wrong setting because my eyes were getting a little old and I missed the decimal point. Instead of 20 hertz, it was 2 decimal zero. And we saw a very different response to what they'd seen on the ground. And so once we finished up the experiments at 20 hertz, we went back and repeated them at 2 hertz, so the investigators would have this whole new data set that we just by accident found on orbit. And a lot of times, research in the laboratory here on the ground, the most interesting research is, I wonder why that happened. And you go and try and figure out, why did that happen?
Well, serendipity was always my best friend when I was doing any kind of a research for my college degree. Yeah, and Mike Hopkins was working with the in-space experiment yesterday. He had some extra time, and he was able to pull that together and do some work in the microgravity glove box. So it's obviously still
developing ultrasound technology and distance telemedicine techniques to utilize this technology for remote medicine on board the space station, but obviously that could apply here on Earth in remote rural locations where you might not have an expert ultrasound technologist, but you could do some remote guidance from somewhere else and have the experts look at the data and tell you, what might be the problem. So all of this is great application for us going on beyond, low Earth orbit and doing exploration in the future, but it's really neat that it actually does apply here on the ground as well.
definitely we're looking at the benefits for humanity from the International Space Station. I want to thank you, Peggy Whitson, for coming to And we're back now with live television from inside the International Space Station. We're looking at Luca Parmitano and Mike Hopkins as they talk inside the Destiny Laboratory module and continue their work. Right now, they're actually both scheduled to be doing an exercise session, so they're likely finishing up a task that they were previously assigned to and getting ready for their exercise sessions. They also were scheduled to be having a teleconference with folks on the ground to discuss inventory management aboard the International Space Station. And this was a private call, and they're likely finishing that up as well. Hopkins was taking some samples of the internal cooling system fluids, part of routine maintenance activities aboard the space station a little bit earlier as well. Right now, Commander Fyodor Yurchikhin scheduled to be getting some exercise, while Oleg Kotov and Sergei Ryazanskiy have some time that is not covered by any particular schedule item. Hopkins also working with some generic urine collection operations to send down to the doctors on the ground eventually so that we can look at how microgravity affects the human body. Parmitano heading over to the Tranquility module, where he's scheduled to be going through an exercise session on the Advanced Resistive Exercise Device, which essentially is an on-orbit method of weightlifting. They can do a variety of different exercises, from upper arm and shoulder exercises to lower torso exercises, ranging from pull-ups to squats to bicep and tricep exercises. All these designed to help keep the astronauts in good health for their work aboard the International Space Station, as well as to fight off the potentially detrimental effects of long-duration spaceflight by helping to minimize bone and muscle density loss that occurs normally, since they're not using their legs and other bodily equipment to move about as much as they would on the ground. The lack of gravity also even has effects that lead to weakening of the heart muscles, one of the biggest, most important muscles in the human body, and has implications to their cognitive abilities and their eyesight. We've noticed that there are changes in eyesight, some of which can be permanent in some astronauts. It's a very individual thing, but we're looking at how to improve and avoid that. Again, it seems that exercise, a very strict program of exercise, and a very strict performance of nutrition, as we discussed in our inset from the Payload Operations Integration Center in Huntsville, are turning out to be our best defenses against those kind of detrimental effects of long-duration spaceflight. Those lessons will help us as we go farther out into our solar system, and we can also bring that back home here as benefits for humanity as we learn how better to deal with things like heart disease and osteoporosis and other ailments that we have here on the ground. And then the scientific research aboard the station also helps us here on the ground, as we discussed with Peggy Whitson, with things such as better delivery mechanisms for cancer-fighting drugs and for identifying where the cancer cells are, so that we can attack them more specifically, rather than just going after any cells in the body that might potentially be involved in the cancer. Whitson talked about the long period it takes often in the research environment. It usually takes 5 to 10 years for research to go from concept to results, and then additional years for it to be turned into drugs, medicines, and techniques to fight disease after all the testing that's required in the laboratory and eventually on humans prior to it being released to the general public. Crew members on board the station awakened at midnight as usual, and they went through their usual daily planning conference, talking with the control centers around the world in Houston, Huntsville, Alabama, at near Munich, Germany, outside Moscow, and in Tsukuba, Japan, as the 5 international space station partners of the U.S., Russia, Canada, Japan, and the European Federation all work together to operate this research outpost. The commander and Russian folks work primarily on preparations for the upcoming departure of Fyodor Yurshkin, Luca Parmitano, and Kara Nyberg as they're getting ready to come home. And then Sergei Ryazanskiy and Oleg Kotov made preparations for their Saturday planned spacewalk. And then all of them got ready and made preparations to welcome 3 new crew members on board tomorrow as Mikhail Turin, Rick Mastracchio, and Koichi Wakata are at the Baikonur Cosmodrome in Kazakhstan getting a final period of rest before they get ready for launch day. Again, getting ready to launch at 10:14 p.m. Central Time tonight are NASA's Rick Mastracchio, Russia's Mikhail Turin, and Japan's Koichi Wakata. We have a small package that takes a look at their backgrounds and their plans for this upcoming Expedition 38 mission. Let's run that now.
The newest members of the International Space Station crew are veteran space flyers, all eager for another opportunity to make a contribution to the future of human exploration. Dr. Koichi Wakata was born and raised in Saitama, a bedroom community of Tokyo. He remembers watching the first moon landing on television and wishing he could fly in space. But since there were no Japanese astronauts then, he put the dream aside as impractical. But he had other interests, including baseball and airplanes.
I was very fascinated by airplanes ever since I was a small boy, and I always wanted to become an engineer or pilot to make and fly an airplane.
Wakata pursued that dream at Kyushu University, where he earned a bachelor's degree in aeronautical engineering and a master's in applied mechanics, and then started his career as a structural engineer for Japan Airlines. 2 years later, when Japan's space agency advertised for astronaut candidates, Wakata applied and was selected in 1992 to begin astronaut training at NASA's Johnson Space Center in Houston. In 1996, he was Japan's first ever space shuttle mission specialist on a flight where he ran the shuttle's robot arm to deploy and retrieve satellites. In 2000, he used his robotics expertise again on the shuttle flight that installed the Z-1 truss and a pressurized mating adapter on the International Space Station. After he finished his doctorate in aeronautical engineering from Kyushu University in 2004, he completed training in Russia as a Soyuz spacecraft flight engineer, and then in 2009 became Japan's first space station crew member as a part of expeditions 18, 19, and 20, and expanded his robotics repertoire to include Canadarm2, Dexter, and the robotic arm on Japan's Kibo laboratory module. He's eager to keep doing what he can to prepare the way for future exploration and improve life on Earth.
I think we can gain new knowledge, new technologies that we benefit in our daily life on the ground by going to space. And also, I strongly believe human space program is a vehicle for the survival of human species.
Michael Turin was born in Kolomna, Russia, an historical town outside Moscow. But he lived in many places around the country, growing up in a military family. His interest in spaceflight did not focus on becoming a cosmonaut himself.
I did not have a period of my life when I was dreaming and doing all I could, overcoming difficulties to become a cosmonaut. I just loved this area.
And he focused on getting as close to it as he could. Turin earned a degree in engineering from the Moscow Aviation Institute and went right to work for the Rocket Space Corporation Energia as an engineer, first specializing in ballistics and software development, and later in methods of training cosmonauts, methods he usually tried out on himself first. After 9 years on the job, he was selected to join the Cosmonaut Corps. Turin made 3 spacewalks during his first trip to the International Space Station in 2001 as a flight engineer on Expedition 3, and 2 more EVAs as flight engineer on Expedition 14 in 2006 and 2007. He's pleased to be contributing to physiological research that will prepare humans for future space exploration, and even more interested in how some of the psychological results will be applied on Earth.
They can be used not just in space exploration, but can be propagated and applied to human relations in general, and are much more in demand in various areas of our human activity, human life.
Rick Mastracchio is a native of Waterbury, Connecticut, and grew up there in the 1960s, interested in the space program, but not with the idea that he'd ever fly in space himself.
When I was a small kid, I didn't know you could even be an astronaut. It never occurred to me I could be an astronaut someday. But I was always interested in math and science. I was always interested when the teacher spoke about aviation-related topics or space science-related topics, when I was in grade school.
He took those interests to the University of Connecticut, the first person in his family ever to go to college, and earned a Bachelor of Science degree in electrical engineering and computer science, which got him a job at Hamilton Standard developing guidance and flight control systems, while he finished a Master's of Science in electrical engineering at Rensselaer Polytechnic. At that time, he saw an ad from NASA looking for new astronauts and decided to apply. What he got was a job offer from Rockwell to work in shuttle operations, and he moved to Houston in 1987. 3 years later, he joined NASA as an engineer specializing in software development, then became a flight controller in ascent and entry guidance and procedures, and was selected as an astronaut in 1996 after 9 years of applying. His first space shuttle flight was the 2000 mission that outfitted the International Space Station's new Zvezda module for its first permanent crew. He made 3 spacewalks during his second trip to the station in 2007 on a mission that delivered a truss segment and a new gyroscope, and 3 more EVAs on a 2010 resupply mission. He sees this station as a means to support inevitable exploration well beyond the neighborhood of this blue planet.
We are meant to explore. We, being the people here on this planet Earth, we want to go out and see what's out there. We want to know more about things, and we can't just do that through robotic systems. We have to send people to see things up close and personal.
Obviously, a very experienced crew heading up to the International Space Station later tonight and tomorrow. Just to run through our coverage of the activities on NASA television one more time. Our launch coverage for the Soyuz carrying the trio will begin at 9:15 p.m. Central Time. Launch is planned for 10:14 p.m. And then the following morning, Houston time, Thursday, November 7, we'll begin our Soyuz docking coverage at 3:45 a.m. and expect a docking to the International Space Station at 4:31 a.m. After all of the docking systems have completed making a firm connection to the International Space Station, and the pressure checks and leak checks have been completed, Soyuz hatches will be opened at 6:40 a.m. Central Time. We'll begin our coverage of that at 6:15 a.m. Central Time. And then following the hatch opening and the welcome ceremonies as the 9 crew members get together aboard the International Space Station and welcome one another, we'll have our video file that provides comprehensive coverage of docking and hatch opening at 8 a.m. Central Time. And then we'll be back tomorrow at 10 a.m. Central for another recap of those activities in the regularly scheduled Space Station Live. Again, the team continues to monitor the systems aboard the International Space Station. Currently, it's orbiting at nighttime, about 250 statute miles over the Pacific Ocean after having just made a pass directly over the eastern coast of Australia. The next pass will take the International Space Station over the Pacific Northwest of the United States and much of the southern portion of our International Space Station international partner, Canada. All systems aboard the station working very well as most of the crew is in the process of getting some exercise or participating in human research sample gathering that'll be used by doctors and researchers on the ground to understand better how long-duration microgravity affects the human body and translate that into things that will help us here on Earth. Crew has an evening preparation for bedtime coming up, and we'll be having a daily planning conference to close out the day's activities and make sure everybody's on the same page for tomorrow's very busy day of arrival of 3 new crew members, hatch openings, and welcome ceremonies. They'll begin their sleep activities at about 3:30 p.m. this afternoon, but before then they'll have a couple hours to relax together, have an evening meal, and actually enjoy some of the last days together as a 6-person crew as Fyodor Yurshkin, Luca Parmitano, and Karen Nyberg are getting ready to come home on Sunday after 5.5 months on the International Space Station. Our coverage of landing events begins at 1:30 p.m. Central Time on Sunday with farewells and Soyuz hatch closure activities. 2 p.m. is when the hatches are scheduled to close, and then we'll begin our undocking coverage at 5 p.m. Central Time. 5:27 is the scheduled undocking time, and then landing coverage will begin at 7:30 p.m. with the Soyuz's deorbit burn, starting the final process of the return to Earth and landing scheduled on the steppe of Kazakhstan at 8:50 p.m. Central Time. On Monday, the following day, we'll have Soyuz post-landing activities in a video file, and then have our normal Space Station Live coverage at 10 a.m. With that, and all systems here in Mission Control and on the International Space Station continuing to work very well, and research continuing on board the space station, this is Mission Control Houston.